So why don't I start talking while I'm getting set up here? So my name is Christopher Stubbs. I am in my day job. I have a joint appointment between the Department of Astronomy and the Department of Physics at Harvard University. So I call myself a half astrophysicist. Part of what I've done on a sabbatical that I took at Stanford at the Hoover Institution was to think a little bit about sort of public domain information in the context of international security and arms control. So strangely enough, at this meeting, I'm not going to talk about LSST, but rather I'm going to bring you what I would consider to be some sort of ill-defined, interesting algorithmic problems in the domain of big data as applied to international security. I hope to pique your interest in this topic, and really I have more questions than I do answers. I'll outline some of the technical, ethical, and legal challenges that pertain to using big public domain information in the international security arena, and hope that really I can stimulate some questions by the audience broadly. So I tried to make a matrix of sources of information running across the top and sinks of information running down the left-hand side. So if you think about, sort of with a little bit in the back of your head, national security and international security applications, there's a domain where nation states generate data that they hold classified, and they are themselves the consumers of that information. And there's this euphemism called national technical means, which really means spy satellites and persuading people to betray their own country. So there are other domains here where nation states actually share information that they hold at a classified level. There's something called the Open Skies Treaty. It's a little known fact that the United States and Russia can reciprocally conduct overflights over one another with 48 hours notice, take aerial photographs that they then share with treaty participants. We call that sort of shared technical means. There's public domain web content, and there's a big initiative within at least the US federal government to harvest that information using something called open source analysis and turn it into some kind of intelligence information. Similarly, information that flows out of the commercial sector and into the government has been a topic of rather recent discussion of late. There are data that are generated in the public domain, lots of different bits and pieces of this. So people will contribute from their home computer or in some personal technology information that they think contributes to the broader good. An example is traffic information. You know, my phone tells the world when I'm stuck in traffic, and that information informs people about where they should go, and I haven't yet understood why that doesn't induce oscillations in the traffic system, but never mind. So there's an initiative underway here in California to capture the accelerometer data off of laptops and use that for early warning of large earthquakes. So there's a whole domain of publicly generated data. The scientific sector generate data as well. Some of it goes into nation states. Some of the scientific data is consumed by scientists, and that's just kind of doing the science thing. There was an initiative a while ago within the federal government to use national spy satellite data in support of scientific endeavors by having scientists be read into certain classified programs. That was an Al Gore initiative under a previous administration. There's a whole commercial sector that consume data from these different pieces. And at some level, the public are also consumers of information. There's a pathway of sort of unintentional release of classified information that sits in this box. There's certainly been instances of information that resides in the public domain influencing the course of human history. The whole sort of social media impact where people talk to one another and generated revolutions in countries in the Middle East. So if you look at this sort of broad array and focus in on the pieces that pertain to national security, whoa, that's interesting. I should look over here, I'm sorry. Wrong machine. So there's been this part that people know a lot about. The part that I want to concentrate is the bottom right-hand corner. And I think the big picture idea here is that the sort of aggregated total of information that is generated by the public is potentially of use. Uh-oh, now what? So the idea here is that the general public generates a lot of data And the public could themselves be consumers and exploiters of that aggregate information in their own enlightened self-interest in the national security arena. So we call that public technical means to distinguish it from national technical means. And the basic concept is that if you look into the future, in the decades ahead, the ubiquity of sensors, the increasing connectivity, and the open flow of information actually provides us as individuals the opportunity to do jobs that we have previously collectively delegated to our respective nation-state governments. And that is to say, the general public could take action on their own behalf directly through the acquisition and analysis of information that has a bearing on national and international security. And I claim, we already have examples of that happening in the sort of social media context. My emphasis here is going to be a little bit different because I think it's actually a somewhat easier problem to talk about physically measured quantities. And we'll use CO2 sensing as an example. So the definition of this public technical means then is the generation, analysis, exploitation, and interpretation of public domain data in the international security sector by the public acting on their own behalf. So what examples might you imagine? Well, here are just some illustrative examples. There's a network of sensing modalities deployed internationally to monitor whether people are undertaking illicit nuclear weapons testing. It includes seismic information, infrasound, sniffing for radionuclides. That's a pretty sparse array of sensors. And they're high quality, high fidelity systems. The specs were written 15 or 20 years ago. And you could imagine actually with contemporary instrumentation complementing that with a much denser network of publicly owned infrastructure. Another opportunity is to exploit the fact that there's this explosion in downward-looking satellites that are owned either by companies or by the scientific community. So especially as our collective awareness of global warming and environmental issues grows, the amount of remote sensing data is going up by a great amount. And you could imagine basically allocating and saying, why don't you monitor all the airfields in Portugal, you monitor all the ones in Spain, let's just keep track of where all the bombers are, and we'll do this collectively because it's just what we want to do. And you can pull up Google Earth and find annotations. It's interesting to go to Google Earth in North Korea and see what people have found who are just doing it as a hobby. There are other examples where people with deep pockets in Hollywood have bought satellite imagery to monitor regions of high conflict using non-governmental organizations as image analysts. I want to use this CO2 sensing example because I think it highlights a lot of the issues and challenges that we confront. So whether or not the international community eventually signs and ratifies a treaty that limits CO2 emissions, let's just imagine that that's going to happen. And think about how this public treaty monitoring infrastructure might have a bearing on that problem. Lest you think that this is a purely academic and largely irrelevant thought process, let me just hasten to point out that the higher levels of the US federal government, at least, is starting to think in this direction. So this is a quote from Rose Gottemoeller, who was just confirmed as the Undersecretary of State for Arms Control and International Security, and she talks about public domain information and how, in fact, the US government is looking at broadening its scope and perspective and drawing upon this as a resource for the future. So here are some, the next two slides contain arguments in favor of and against being proactive in this domain. So here's a list of arguments in favor of the technical community, of which I count all of you. So this is the buy-in slide. This is where you buy into the idea, just to be explicit, right? So what are the arguments in favor of our supporting this sort of public technical means? One argument is technology, I guess, allows us to really take full advantage of our individual and collective liberty. If we as individuals decide that we want to spend $200 to buy a CO2 sensor and use that as, okay, I know how to do this. If I decide that it's in my interest to buy a CO2 sensor and contribute to the global knowledge of CO2 concentration, that's my right, and I should be allowed to do that. If I convince 12 of you that we should do it together and host that information on a website, similarly, that's our collective right, I assert, to do that. So it's an expression of individual and collective liberty. Secondly, this treaty monitoring enterprise has been a monopoly. It's been a monopoly held by nation states. And, you know, look, I'm not an economist, but I'll just stick my neck out and tell you I think monopolies are not cost efficient. And so providing some kind of competition to the nation state monopolies will drive costs down, improve performance on that sector, and everybody wins. Third, you know, I'm not sure how inevitable history is, but it seems inevitable that there's this explosion of growth of sensing modalities, explosion of communication and data transfer capability, and it seems to me honestly inevitable that some subset of humanity is going to decide to do this. And so it's just a question of is n equal to 1, 2, 3, 4, or 100,000. Finally, technical agility. Imagine hypothetically one could persuade a smartphone vendor to include in subsequent generation smartphones the green option or some sensor package as an add-on for which I would pay a premium, and then that data would be contributed up into the cloud for broad utility. The turnover in technology is much more rapid in this domain than it is in that rather ossified comprehensive testband treaty monitoring system. So the ability for the insertion of new technology and capabilities in this domain, I think, is much faster than it is in the government sector. So that's my set of arguments in favor of doing this. My arguments against would look something like this. Basically, what the hell business is this of yours? Right? This has been the purview of nation states for decades, and essentially individuals have no right to step up and play a role here. My rebuttal is no, I don't think so. That's not my perspective. A second point of rebuttal would be the public, broadly construed, does not have the expertise or competence to properly interpret the data that would flow here and draw appropriate conclusions. And this sort of goes to this whole issue of sort of crowdsourcing science and whether in fact the collective intellect has some kind of, I guess, emergent collective expertise or not. But that aside, there are certainly many examples of amateur communities that acquire very, very in-depth technical expertise, okay? And I think if you just look at the level of sophistication that goes into open source tools and open source data, some of which have been discussed here, I think that demolishes this argument. Counter-argument number 3 is this is just too dangerous, that you are putting at risk individuals who happen to reside within countries that are repressive or non-cooperative, and their participation in this endeavor threatens them as individuals, and it just isn't worth it. And I'll spend some time trying to address that issue. Finally, is this sort of, you know, bad actor argument, which is that if we were to institute some worldwide repository and data exchange mechanism for this, it will be undermined and abused by countries who either want to stifle the information or put bad information into the system for some nefarious purpose, and you cannot architect a system that is robust enough to guard against that. And I think the biggest rebuttal to that is, I'll talk about some sort of data validation schemes in a little bit, but at some level, there'll be a tipping point where if the flood of information that we have is large enough, the number of cross-checks and balances that we can bring to bear, I think, can help overcome that technically. So let's take CO2 treaty verification as a concrete example here. So what are some of the facts that we face? So you can use differential absorption at infrared wavelengths to determine the CO2 concentration in some path length, and you can build an instrument for about $100 that will deliver to you high accuracy, high precision data that is relevant to this problem. So the sensor technology is affordable for that kind of money, and the sort of implementation that I have in mind is that some small fraction of humanity deems it an appropriate investment of their personal resources to get such a sensor. I'm really sorry about this, guys. If I could turn off the wireless, I would, but I don't have that in front of me. It's true that you can make CO2 concentration measurements from satellites, and NASA has satellites to do that, but it turns out that the spatial and temporal sampling that you get from satellites is not a great match to the global circulation models that you need to populate with CO2 data. And so actually, the combination of remote sensing data and ground truth from a network of ground installed sensors does provide powerful constraints and lets you really understand what's going on. So imagine hypothetically a group of 1,000 or so citizens in China just decide for whatever reason that they want to support this endeavor, and that those individuals are willing to actually go and acquire sensors and emplace them on the appropriate places in China to actually monitor, for example, the periphery of coal-burning power plants, because there are these point emitters of CO2 that actually dominate the emission budget. So the question then technically is, how could we help these people install a mesh of CO2 sensors, collect the data, validate it, and make it available for crowdsourced analysis? That's really the technical challenge that we face here. So what are some of the sort of shifting over to technical challenges here? So here's a list of unsolved problems for you. So how do you provide access to appropriate validated sensors? How do they get calibrated? How do you ensure data integrity against both spoofing and deception? So I'm going to put this in the category of unsolved computer science, algorithmic, and architecture problems. I don't know how to do that. There's a signal processing problem. How do you discriminate the signal of interest against clutter and noise? That's pretty generic signal processing and is not unique to this. We don't, to my knowledge, have any standards for data and metadata that would allow for trivial fusion of these different sources of information flowing together. A really interesting aspect of this is, how do you collect the interesting information out of this while preserving anonymity and protecting individuals who participate against retribution from their local government? In the understanding that in some places of the world, it may well be that the local government is, shall we say, non-cooperative in this endeavor. What are the data transfer mechanisms that, again, retain the integrity and provenance of the data without compromising any individuals? And here's one that I'm just completely at a loss as to how to resolve, and that is that the information that is generated by these systems almost necessarily has the position and timing information as an essential component of the data stream, because you want to know what's going on where, but at the same time, you want to retain that information without linking it to any particular individual. And furthermore, how do you give GPS and time-tagged information in a way that doesn't allow the local government to just go over and pick all these things up off the ground and say, thank you very much for telling me where all these are? So how do you basically, I guess, at the same time capitalize on the space-time timestamps, but protect individuals and preserve the integrity of this network? And that depends a lot on what the requisite, what the tolerable uncertainty is in space and time, and as to whether you can introduce specific jitter there. So the legal and ethical aspects of this are almost more interesting than the technical parts. And there are some very interesting breakpoints here. So there's a big difference between saying, I'm going to provide an incentive. I will pay $200 in Bitcoin equivalent to whoever posts a picture on YouTube of tanks on the Ukrainian border within, this time bracket, right? Where you're basically incentivizing people to go and do things that put them at risk. So that's not what I'm proposing here. Really, what I'm suggesting is that we empower individuals with the technology for them to take action if they deem it in their self-interest. So if there's a big difference between this and saying, you can download the do-it-yourself CO2 sensor instruction assembly manual from some fictitious thing, http://savetheworld.org. And those two things are really ethically quite different. And I'll tell you, the US government is struggling with what they're doing here right now. Okay, I don't think that we currently have an ethical rule book on how to deal with that right this second. So just one more overhead on the sort of legal and ethical aspects and how that interplays with technology. So an interesting element of this is the extent to which the sensors in question are actually linked to individual people. And if I carry the sensor in question around with me on my cell phone, how do I provide that information up to the system without it being uniquely tagged to me as an individual, realizing that governments can do metadata analysis, they can see where my cell phone went, they can see where the data come from, and even if it's masked with some IP thing, they can put two and two together. But if I obtain and deploy some solar-powered sensor that I just emplace, and I break the link to me as an individual, and if that device provides data up into the system, then this retribution problem is a little bit easier. So you can imagine a variety of possible configurations shown here pictorially on the bottom left, where I think these are the two extremes of the spectrum. On the far left-hand side is where the sensor is intimately related to some personal technology device of mine, and the data exfiltration path goes over some cellular wireless link where the communication path is also attributable to me. So that's the left-hand edge. This is where retribution probability is high. On the far right-hand edge, I think, is where we've maximally broken the link between sensors and people, and the idea is that there's some standalone sensor drawing its power from who knows where with a completely independent data path. And I'll talk about data links that actually circumvent the local network infrastructure in a second, and in principle, there's everything in between. So the technology part does sort of link to the legal and ethical part at some level. So we can think about this layer by layer. We can think about a sensor layer, an appropriately secure communications layer, data archiving, anonymization of data, the analysis part, how do we empower people to actually run algorithms on this stuff, and where do the results go? So on the sensor layer side, this is really a hardware thing, and I guess this is not so much a hardware audience, but we need to identify the physical signals of interest and develop cost-effective sensors one way or another, calibration and tamper detection issues, how do we impose data standards? There's this whole geographical location thing, which I claim is a hard unsolved problem. And it seems prudent to look ahead and think of some kind of data validation provenance tag, which will allow us to ascertain data validity downstream. The communications layer is also interesting. How do you move the information from the sensors to the archive with immunity from some kind of blockage in the local network, or some kind of traffic analysis that let you determine where these sensors are? You don't want linkage to individuals, and it has to be immune to data corruption, be that either willful or accidental. And in that regard, one of the interesting ideas we've been talking about is the idea of actually a dedicated satellite network, which just completely circumvents the local network infrastructure. So imagine a satellite in geosynchronous orbit over Asia, where even you could imagine persuading the US government that it is in our interest to fly a satellite where we make the protocols widely known, and we say if anybody in the world would just so happen to care to emplace sensors to facilitate treaty verification, here's your uplink. And that would be an interesting thing. It needs to be robust against denial of service attacks, and I think that's a possible way to just completely bypass the local communications path with highly directional antennas on these sensors. Presumably then all this information would flow into some data archive that lives somewhere, which would be empowered with some kind of data access mechanism. We have no metadata standards, and I think this is a possibly appropriate role for non-governmental organizations or potentially even academia. We have to do data validation and some kind of scrubbing that again protects the anonymity of the individuals who are contributing to this endeavor. And then there's a whole data analysis thing. Okay, so I've told you the data collection is hard, the data transfer is hard. If the public are going to analyze these data, they need some kind of method to do that. And I'm sure people in the audience, this is the one example from my subfield that I know about. The Galaxy Zoo endeavor enlisted 250,000 people to do eyeball analysis of images of galaxies by incentivizing their participation in this process. So how can we incentivize the broader public and the expert subcommunity to be engaged in this in their own behalf? And again, part of the galaxies of success was complicated cross-validation of analyses done by independent individuals, which can help guard against contaminated analysis. So there are, I think, some actually rather fruitful research opportunities here, one of them being how do you defeat your computer from spontaneously going and trying to connect to the internet. I think, so I've come to you with some sort of fuzzily posed big picture problems. There are open issues having to do with architectures for data collection and transfer, data and metadata standards, the development of sensors, playing with some toy networks, and just trying to put some stuff together that would be sandbox instantiations of this, and then throwing at that a red team of bad guys whose job it is to break and defeat the system. And also just resolving this fundamental tension between both wanting to exploit time and spatial information and at the same time conceal it. There's not a lot of literature on this. I'm only aware of a couple of papers, one of which I just happen to be a co-author on. So Sid Drell and I wrote a paper for the engineering community, and there's been a white paper by the NTI effort, which is headed by Sam Nunn, to think about this. And I just want to thank the organizers of the conference for the invitation and thank my hosts at Stanford for giving me the chance to think about this. And I'm happy to take whatever questions you might have. Thank you. Yeah, so let me just repeat the question. The very observant point is, this is not just relevant in the national security arena, but also just for environmental monitoring. And I completely agree, and that's a much easier problem than this one, I think. I hope. Yes, there's a lot of overlap. I totally agree with you. Yeah, so the gist of the question is, how come the hell I'm standing up here talking about this? Well, I have two answers. I guess the one answer is, you know, when you're a physicist and you start to get mid-career like me and you look ahead, you have a couple of options. One is to realize that you're becoming research irrelevant and throw all your time into teaching. That's one option. Another is to just kind of go off the deep end. And another is to say, oh, I'm a physicist, I can solve any problem in the world, let me at it, we're smarter than anyone else. And I've seen lots of examples of all of those. And there are not many physicists of my generation who were involved in arms control. My predecessors worked on the Manhattan Project, and a lot of them were active in arms control afterwards. But in my generation of physicists, there actually aren't that many, because, you know, we didn't make those things. It's not our fault. It was those other guys, those geezer guys. And so I'm actually thinking a little bit about whether, you know, the tail end of my academic career might go more in this direction when I don't do observational cosmology anymore. And when LSST is a roaring success, and you guys are showing us how to analyze all the data, I got to find something to do. Yeah, well, I mean, I might say that I think the healthcare information arena is similarly adversarial. But yeah, that's a good question. So in other words, pick an easier problem, solve the easier problem first. I think the environmental monitoring one is a good example. And I think I'm not actually aware of a successful current technical implementation end-to-end that's a citizen science environmental monitoring endeavor. And it would be interesting to contemplate that as a near-term objective. I think that's a very worthwhile point. Point taken.